Now let's find an estimation for the square root of 30 and 34. We are going to do the same procedure as we did before. The first thing you want to do is to recognize that both square root of 30 and 34 lies between the two perfect squares, which are 25 and 36. Now, having known that, we will draw the number line. So let's start off here and then draw the number line, say end up there. Now let's write what each value here is. So this will be 25. So we want count up to 36, the next perfect square. So this will be 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there you go. So now let's write what each value is. So this is 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And as always, we don't want this little part here. Okay, now let's write what the side lengths are. So square root of 25 is side length 5. Square root of 36 is side length 6. Now, like before, we have to first identify the center position between 5 and 6. Now, one way to do that is we could count the number of squares between 5 and 6 and divide that by 2, for example. So how many squares you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. You have 33 squares. So where would the center be? It will be 33 divided by 2, which is, if it's 32, so 16 and a half. So let's count 16 and a half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and a half. It's right there. Now, just to make sure that we got the center right, it looks like the center graphically. So let's make sure that there is 16 and a half squares on this side as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and a half. So we are right. So we have now, we know now where the center lies. So as before, if this is 5 and 6 and this blue line segment is exactly between 5 and 6, then this number here has to be, should be 5.5. And like before, what we do next is we place 4 dots on this side and 4 dots on this side so that they are equally spaced. So let's try doing that. So I say 1, 2, 3, 4, 5. Looks okay. So let's try on this side. Oh, 1, 2, 3, 4, 5. Okay. Now I have done a mistake here. I have placed 5 points, but we only need 4 points. Why is 5 points not right? Because if you put 5 points, this will be 5.1, 5.2, 5.3, 5.4, 5.5, but 5.5 should be here, so we are not correct. So we want to get rid of it and try it one more time. Try to get the line segments right. We want to place 4. So let's redo it. So I say this is 1, 2, 3, 4. Wow, it doesn't look good either, because this like segment here is smaller than this one, so we'll have to try again. So let's try again until we get it to our satisfaction. Let's say it's here 1, 2, 3, 4. Well, this one is now bigger, so that's not good either, so let's try again. So we are going to try again. We have tried so many times now. So 1, 2, 3, 4. There you go, we got it. So now it looks nice, it looks evenly spaced. So we do the same onto this side. So it would be, let's say 1, 2, 3, 4. Looks good. So each section, you can say they are equally spaced. So we have got it right. So now let's number them. So 4 points on this side and 4 points on this side, and that is what we need. So therefore this will be 5.1, 5.2, 5.3, 5.4, and on this side this will be 5.6, 5.7, 5.8, 5.9. Okay, so we have the number line ready to read off each of these square roots. Actually, we can read off any square root between 25 and 26 using this number line. So let's first do the square root of 30. So where is 30? 30 is right here. And you can see 30 is closer to 5.5 than 5.4. So my estimate of square root of 30 is 5.5. And let's do the same for 34. Where is 34? 34 is right here, and you can see 34 is really close to 5.8, this number here. So therefore I say my estimate of square root of 34 is 5.8. Now the same methodology can be used to estimate the square root of even larger numbers.